So thank you, everyone, for being here today. Thank you for inviting me to give this presentation. So I will talk about the OpenRAN Brasil Program, an initiative that we have in Brazil. Well, a little bit about me. My name is Lucas Bondan. I'm a research and development coordinator at the Brazilian National Research and Education Network, and also an invited researcher at the University of Brasilia. And I have been involved in this initiative, but before we start, just a quick contextualization about OpenRAN. Well, let's start with the characteristics of traditional radio access networks, or at least the bad ones. As we know, they are usually proprietary, predefined radio, hardware and software with closed and embedded interfaces, and they usually come from a single vendor. So when you try to use different solutions from different vendors, you might face some performance reduction, and also it becomes a barrier for innovation, and it basically makes you a hostage of a single vendor. So what OpenRAN aims to do is to break this vendor lock-in, and it's basically composed by three main elements: the radio unit, the distributed unit, and also the centralized unit. And they are all programmable software-defined, have a programmable software-defined operation with DDU and DCU running as virtualized software on vendor-neutral hardware. They also have open interfaces. Opening and standardizing interfaces can make network deployment more modular, and also it enables us to have multi-vendor setups. So the impact of OpenRAN is then there is no more vendor lock-in. We can adopt common off-the-shelf hardware, network agility and flexibility is improved, also an increased opportunity for innovation, and also costs reduction. So then we have the OpenRAN Brasil program. The OpenRAN Brasil program is an initiative in Brazil carried by the National Research and Education Network, and it is divided in three phases. In phase one, the main objective was to build an OpenRAN testbed and offer it to researchers in Brazil. In phase two, we are creating our own radio unit with national technology, and on phase three, we are expanding the testbed to have at least one island in each region in Brazil. I will give more details about each phase, each one of these phases later. And this is the timeline of the project. We started back in 2022. Phase one is already concluded, and now we are still running phase two, and phase three started earlier this year. And the budget for the whole project is around $20 million. Together with us, as I said, RNP is coordinating the initiative, but also executing it with CPUKD, Eldorado, and Inatel in Brazil, and we have the support from the Ministry of Science, Technology, and Innovation. Together with us, we also have some universities and some researchers from different institutions across the country, and also some startups. I will give more details about the involvement of both working groups and startups later. Well, regarding phase two, as I said, the main objective was to build this testbed and offer it to different communities so they can explore and test their OpenRAN solutions in the country. And also we aimed to foster research, development, and innovation in OpenRAN through open calls for working groups and startups, and also train specialized workforce to know and to start learning about new OpenRAN technologies. So the testbed has been concluded. We have two islands, operational islands right now, and they offer 5G OpenRAN, optical access, packet transport networks, optical networks, cloud and edge computing, data processing for 5G OpenRAN antennas, and also the RAN intelligent controller solution, CUs and DUs. They are all available for experimentation. So this is the operation of both islands in a nutshell. If you want more details, you can access this article we published in the IEEE Communications magazine. But it is basically a testbed composed by two islands, one in the city of Campinas in the state of São Paulo, and the other one in the city of Rio de Janeiro. They are around 400 kilometers apart from each other and connected by a 10 gigabits per second link. And they employ the OpenRAN Alliance split 7.2x architecture with the radio unit disaggregated from the distributed unit. We have up to 7 servers employed in these islands, 3 indoor 5G OpenRAN antennas. Some outdoor antennas are coming to the testbed as well. In the packet domain, we employ leaf spine topology with P4 switches, programmable switches. And in the optical domain, we have the PON and DWDM. Regarding the equipments that we are using, the OCP-approved equipment that we are employing right now is the UFI space, and the role in our testbed is to aggregate radio units in the front hall and also operate in the back hall, aggregating the traffic towards the core. So in phase 2, we also had some open calls for working groups with the main objective to foster research and development in technologies related to OpenRAN, to add or improve capabilities and functionalities of our testbed. So each one of the working groups received around 30,000 US dollars, and 6 working groups were selected, and they started their work in the testbed in November 2023 and ended in March this year. We also had a similar open call for startups where the objective was a little bit different. We wanted them to bring their solutions and employ it and test it in our testbed so we could prove the flexibility, adaptability, and also the intelligence of the testbed. The total budget for all the 6 selected startups was around 100K, and the duration was 6 months. It's important to emphasize that despite the duration of the funding was a little bit shorter, both the working groups and the startups still have access to the testbed so they can perform their experiments. And the testbed is available for everyone for free. Any proposal, you just need to fill a form with your interest, how you want to use the testbed, and any research, education, innovation proposals are eligible to use our testbed. Every proposal is evaluated by a specialized committee. We are only bearing commercial proposals. Like, we are not giving the researchers for commercial purposes, so you cannot use for that. Well, regarding phase 2, as I said, we are creating our own radio unit compliant with the OpenRAN Alliance standards. We also are performing some research in the development of XApps and RApps, and performing some cybersecurity risks analysis over OpenRAN. So those are the characteristics of the radio right now. The first prototype was already concluded. The second one is under development. It will be released by the end of November this year. And we are also evolving this, the development environment that I said. This development environment works like a blueprint that you can download and start developing your own XApps and RApps, and then migrate them to the physical, real OpenRAN topology. We are also developing our own XApps. 4 of them were selected, one for a distributed RAN intelligent controller, another one for energy consumption optimization, smart network slicing, and also a self-organizing RAM. So finally, but not least, about phase 3, we are expanding the testbed. We already have 2 operational islands, but now we want to have at least 1 island in each region of Brazil, all interconnected by RNP's backbone. So we also want to perform research and development on applications only possible in those OpenRAN infrastructures. And the strategy to expand the testbed is through open calls. So we first started a host certification process that was an open call for proposals to certify parties interested in hosting the new testbed islands. So we received 12 proposals. From those 12 proposals, 10 were eligible and now are certified to go to phase 2. Phase 2 is basically the applications call. So we are receiving proposals to found applications to use the testbed, and these proposals could indicate which certified host they want to partner with. So if they get approved, the host will then receive the equipment, and the application proposals will receive the funding so they can develop their applications. Well, and this is what we envision for the expanded topology. We are using the aggregator routers to connect the whole infrastructure together, and hopefully we are going to have a unified 5G core for experimentation. So some achievements, indicators, and next steps for the program. We already have more than 20 experiments. I need to update the slide, but 6 were from the working group, 6 from the startups, 1 from an operator, 2 from industry, and 5 from academia. 13 of them were already concluded, 4 are still running, 2 are in negotiation, and just 1 was rejected. It's important to emphasize that we do our best not to reject any proposal. We want to give you the resources, give you the access to the testbed. So when the proposal comes, we reach out to the proponent and try to figure out the best way we can cope with the demand that he's asking for. Well, we have more than 250 professionals involved, researchers, students, technicians, developers, project coordinators. So it's a big team working together in this program. And we also made some studies. The first one was a comparison with the IEEE 5G 6G innovation testbed. They defined 33 use cases for OpenRAN. 5 of them were already validated in our testbed. 20 of them are subject for validation. It means that our testbed is capable of validating those use cases, and only 6 are not supported today. And we also have more than 30 publications between scientific papers and presentations, and also some demonstrations and short courses. So what's next for the program? Well, we are always adding new capabilities to the testbed. We are studying how to add GPUs for artificial intelligence processing in the infrastructure, also testing new OpenRAN software stacks. The new radio unit prototype of phase 2, as I said, is planned to be released in November this year. The testbed expansion of phase 3 has already concluded the host certification, and we hope by the end of this year we will have selected the applications proposals. We also have a panel discussion in Internet to Technology Exchange later this year, and we already performed those demonstrations during some events in Brazil. The demonstration we have right now in these events is 2 minutes OpenRAN infrastructure. Like we can build an OpenRAN 5G network in under 2 minutes, and it's pretty interesting. And we are getting this demonstration in many events as we can. So to conclude, we believe that OpenRAN offers a promising view of a more open, inclusive, and efficient future for telecommunications network. If you are interested, you can access our website. As I said, the testbed is free for everyone to use. Unfortunately, the form that you have to fill is in Brazilian Portuguese, but if you are interested to partner with us, collaborate with us, use our testbed, just reach us out. We can figure out a way to collaborate and advance in the OpenRAN development. That's it. Thank you.
Thank you, Lucas. Hey, any questions for Lucas?
Thank you very much for the presentation. So what type of communications are supported by this 5G infrastructure? I'm wondering if eMBB or URLL type communications are supported or not. Typically in Brazil, you have many industrial IoT applications.
Yeah, right now we have some user equipments like cell phone connectivity, and CPQD has some proof of concepts using drones. but it's basically 5G connectivity. If your device has a 5G connectivity, it can communicate with our infrastructure. So we have also some CPEs connected that can distribute the 5G, can connect to the network by using 5G, and then distribute wireless Wi-Fi connectivity to other devices. But it's basically a 5G connectivity.
Just standard.
It's standard 5G, yeah.
Nice presentation as always, Lucas. I was curious, you had 3 submissions for industry. Do you recall which industry or verticals you were supporting?
Well, let me see if I remember them. The first one was an open roaming proposal. They wanted me to perform a seamless switching between 5G and Wi-Fi. The other ones, I don't remember exactly which one were them, but they are all related to network operators or industry, like fabric control, controlling fabric devices and something like that. And the other one was this one related to open roaming.
Okay, so nothing like agriculture?
No, not at this time, yeah.
So any more questions? I have one for you. So with the EvenStar program, we're working on an OpenRU. It's one of our ambitions. Can you share how your OpenRU, can you share a bit more about it? Like, what was the hardware underneath? You know, what were you using? Processors, that kind of stuff, what frequency bands?
Yeah.
Just so we can get a feel.
We are aiming right now, I mean, the original project aiming to the band 48 and band 78 operation. Right now, we are only operating in the N78. We are using AMD Xilinx FPGAs for the programmability. We faced some problems because the original project was aimed to 8 antenna operation, but the AMD chipset had some limitations that made us go back and try only a 4 antenna configuration. Yeah, but more details, I have to reach you out afterwards because I don't remember every single one of them.
Yeah, that would be great. One of the things with the original EvenStar hardware is we have the 8x8 hardware radio based on RF SoC from Xilinx AMD, but working on the FPGA code and even the operating system that's sat on top of that, that's something we've been trying to build a community around to push forward. So maybe there's an opportunity there to collaborate.
Yeah, let's discuss that.
Any other questions? Okay, well, we're really motoring here, so I propose we keep going, and then we'll have a longer time for break. If everybody's okay with this. So thank you very much, Lucas.
Thank you.